everybody. This discussion is about accessing the medium in mobile communication in a wireless network. What is actually accessing the medium or media access? So accessing the medium is nothing but a wire in case of a fixed network. It could be any kind of wire. It could be a coaxial cable, it could be optical fiber cable or any other cables, right? So when you're going to access the medium, what will you do? You'll just first find out whether the medium is free and then you'll start sending the data. So this is the scenario in a fixed network. In case of a wireless network, the medium is going to be air, wherein the packets are sent through electromagnetic waves. Can we use the same medium access methods from fixed networks in a wireless scenario? Is it possible? Let us find out. Let us take one such method which is called as CSMA-CD. CSMA stands for Carrier Sense Multiple Access. CD stands for Collision Detection. So Carrier Sense Multiple Access with Collision Detection. So how does this technology works? So whenever this is the case of a fixed network. So the sender is directly connected to the receiver through some kind of cable. So what the sender will do? The sender will first check the carrier, that is the cable, and find out whether the carrier is free. And if it is free, it will send the packet to the receiver. If at all something goes wrong and a collision occurs at the receiver, the sender will hear the collision because the sender is directly connected to the receiver. So this is the case of a wired network or a fixed network. Let us find out whether the same method can be used in a wireless network. Or what happens? The sender A is going to send something to B. So the sender doesn't know how far B is. In case of a wireless scenario, the signal strength proportionally decreases to the square of its distance. So what happens? Sometimes the sender might not receive the collisions or might not hear the collisions that happen at the receiver's side. So the sender will think that everything is done, but actually the packets would have not reached the receiver and some collisions might have happened. So this is a problem in a wireless network. So let us go and discuss the actual problems that happens in a wireless network when we make use of the same methods that we use in the wired scenario. One problem, the first problem that we are going to discuss is the hidden and exposed terminal problem. What is hidden terminal? Let us suppose there are three terminals A, B and C. A and B are in a range, means A can hear B and B can hear A. And again you have C, again B and C are in a range, so B can hear C and C can hear B. But A and C are out of range, which means A cannot hear C and C cannot hear A, because the signal strength proportionally decreases to the square of its distance in a wireless scenario. So A is not audible to C and C is not audible to A. So this is the case. Now A wants to send something to B. So it just looks into the medium, it starts sending. Now C wants to send something to B at the same time. C also looks into the medium and it also finds the medium to be free and it starts sending. But actually both of them have sent the data at the same time, which gets collided at B. But this is not known to both A and C. So this problem is called as a hidden terminal problem, where A is hidden to C and C is hidden to A. This happens only in a wireless network. And now coming to the next problem, which is called as the exposed terminal problem. This is quite interesting, where C wants to send something to D. D is somewhere else, somewhere away, okay, from both A and B. So C wants to send something to D. It goes and checks the medium. But at the same time, A and B are conversing something. That is, A is sending something to B or B is sending something to A. Now C goes and checks the medium and assumes that the medium is busy. But it has nothing to do with the medium where A and B are conversing. It is going to send something to D. So if D is free, it can receive the data which is being sent from C, but C assumes that the medium is busy. So what happens? C will wait until A and B completes, which is not absolutely necessary. So this is called as the exposed terminal problem, wherein C is exposed to B. So this is the first case of hidden and exposed terminal. And the next problem in a wireless network is the near and far terminal problem. So coming down here, you have again three terminals A, B and C. Now we all know that in a wireless network, the signal strength decreases proportional to the square of its distance. So now A wants to send something, A is sending something, B is in between. What B will do? B will drown the signal strength of A in such a way that C cannot hear A. A wants to converse to C, but A will not be able to send anything to C because the in between B will drown the signal strength of A, and so C will not be able to receive anything from A. If for example C is an arbiter in allocating works for every terminal, for sending writes and all those things, A always remains far from C, and A will never able to send any data to anyone. So this problem is called as near and far terminal problem. So I'll just sum up. If you are going to make use of the medium access methods which is being used in a fixed network, it doesn't work out in a wireless scenario because of this hidden and exposed terminal problem and near and far terminal problem. So what should we do? We have to go in for a new method, or we have to add some more additional, or we have to complement the existing method so that it can be able to support the wireless network also. So what are we going to do? So let us take the same example. Okay, the three terminals. We know there is a hidden and exposed terminal problem and the near and far terminal problem. Now we are going to have a new method which is called as MAC-A. MAC-A stands for multiple access with collision avoidance. So this method will avoid collision. So how does it happen? So again let us go on to the three terminals A, B and C. A is in the range of B and C is also in the range of B, but A and C are out of range. How they will let their existence known to the other? How A will let know C that A is existing, or how C will let know A that C is existing? So this we are adding a little bit more to the existing CSMA CD. Okay, so what we do here, whenever A wants to send something to B, or B wants to send something to C, or C wants to send something to B, any terminal to any other terminal, before sending the data, actually what the sender has to do is, the sender has to send a small packet which is called as RTS. RTS stands for request to send. So before I want to converse something, I should ask you, can I converse? Okay, the same thing, if A wants to send something to B, it sends an RTS to B. Now C also wants to send something to B. Okay, C will also send a RTS to B. Now B will decide with whom it will converse. If B wants to converse with A, then B will send a CTS to A. What is CTS? Clear to send. Okay, now B acknowledges A and say that you can send your data, and now B will become busy, so C will wait. C has to wait. Okay, now once receiving the CTS, A will start sending the data. Once everything is over between A and B, now B will come to C and B will send a CTS to C, and now C can start its conversation with B. It can start sending its data. So we have avoid collision here, and the hidden and far terminal problem is avoided here. hidden terminal problem is avoided here. Now coming to the exposed terminal. Okay, now what was the exposed terminal problem? C wants to send something to D, but since A and B are conversing, C is waiting unnecessarily. So how this problem is solved with this method? Now again with this RTS and CTS. Now what C will do? C has to send a request to send only to D, and so it will not worry about A or B. Okay, and now B wants to send something to A and C to some other terminal. So C will not have to wait for B or A or anybody to complete. C will carry on with its own conversation, and B and A will carry on with their own RTS and CTS and data, and C and D with an RTS and CTS between them and the data. So therein the exposed terminal problem is also solved with this method. Now, so that's it. To sum up, I could say that medium access for wireless network is quite different from those that is being used in a wired network. We have to complement the existing ones, or we have to devise new methods to access the medium. So here we have seen one method which is called as MAC-A. Okay, so which makes use of this request to send and clear to send package to avoid the hidden and exposed terminal problem and the near and far terminal problem. Thank you.